Assalamualaikum warahmatullahi wabarakatuh. So today we will present about our group project, Investigation and Analysis CLK SIM Dashboard. Before we begin, this is the team that worked together and gave our full effort to complete this group assignment successfully. So we have Adam Muhammad bin Nasir, Muhammad Umar bin Ahmad Zaidi, Muhammad Akademia bin Zamzuri, and Megat Mas bin Megat Muhammad.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Muhammad bin Nasir and I'm going to walk you through our dashboard. So first of all, we have count of records, which is the total number of data, and the total number of data that we have been collected is 5480. And then we have the percentage of event type. We have 6 event type, which is DDoS, normal, other, SQL injection, phishing, and ransomware. This percentage is based on the count of records. And then we have the percentage of protocols that associate with event type. We have FTP, POP3, DNS, HTTPS, SMTP, and others. So for every protocol, it is associated with event type. As example, for FTP, we have DDoS, normal, other, and SQL injection. Okay, then we go through the company that have been attacked back the most. So the company that have been attacked the most is Thomas Ltd by 23 times. And you can also see others company like Brown Ltd, CC William and CC and Gonzalez Group. Okay, then we go through our map. So for the blue point, it is the source, and the yellow point is the destination. And the red line means the connection between the source and destination. When you press the blue point, we can get the information about it. So as example, this one, the source country is Ghana, source city is West Miko, destination country is Mozambique, destination city is Post Alexandria, event type is SQL injection, event severity is low, and we get the message. Okay, then we also have the bar chart about the event severity for each event type. So as example, for DDoS, the low is 1342, high is 770, and medium is 616. Then we go through the table that says top 5 source IP, top attack destination IP, and count of record. So by this table, we can see the source IP that have been attacked the destination by many times. And we can be more careful with this IP next time for prevent the attack. And the last one is the table that says the most attack date, the event type, and count of record. So by this table, we can observe the most attack date. As example, right here, the most attack date is December 14, 2023 at 7:27:08 seconds. And the event type occurred is DDoS, and the count of records is 22.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akademia bin Zamzuri, and I'll continue about the detection phase, or we can call it filtering phase. Okay, for the filtering phase, we can see this the type of attack and the protocol that we use. Okay, first, if we want, for example, we want DDoS attack only, and using the protocol DNS, you can click here. So it will filter to the more detail. So the count of records now is 506, DDoS 100%, and DNS 100%. Okay, yes, we can look here. Thomas is the company that got most attack in December 13 to December 15. There's total of 22 compared to the others. Okay, for the right side, we have to look the map. So this is the map on the DDoS attack with DNS protocol. Okay, you can hear the blue one is the source, and the yellow one is the destination, that is the victim, and the blue one is the source, that is the attacker. So for example, we can see this one, the attack. This is from Venezuela, and the severity is high, so it's dangerous. So here is the destination. So after that, we can see all the severity. So we can look here for the DDoS, it's mostly low severity attack from 275 attacks. It is low. Okay, we can see here is the source IP and destination IP. So from the source IP, we can continue to beware from this source IP, that is attacker's IP. After that, we can see the most attack date about the DDoS attack. For example, this one, the most attack date is December 13, 12:55 AM. That is the most, there is 11 attack. And after that, we can filter it by more specific time. For example, we want December 13. So we choose here December 13, we choose the time. For example, we choose 1 PM. 1 PM to December 13 also. To, for example, 6 PM. Okay, click the update button. So we can see from 1 p.m. to 6 p.m. we got 33 attack, 33 records. You can see all the information. Same, equal, the severity is equal, we got the source IP, and we got the most attack time. So we can see here is in 411, it's the most attack time for DDoS. Okay, that's all from me. Thank you.
Okay, my name is Muhammad and I'm gonna show to you how to use VirusTotal. VirusTotal is an online platform that can scan the IP address and detect whether the IP address have virus or not. Okay, so in many cases here, I will choose the phishing one to copy the IP address. So I will copy the IP address of the phishing cases and paste it on the VirusTotal. Okay, so VirusTotal show that the IP address has a malicious activity. Okay, so we can see it here that Bitdefender. Okay, the Bitdefender tell the IP address is a phishing. Alpha Mountain tell that the IP address is a phishing case, and others. Okay, so in VirusTotal we can also watch the detail of the IP address. We can also see the basic properties, where it's from. In these cases here, the IP address is from China and the continent is Asia. And we can see the last HTTPS certificate, the RDIP, and who is lookup. Okay, next one I want to show the normal one, which is the the normal IP address link. Okay, so I'm going to copy the normal IP address link and paste it on the VirusTotal. Okay, after we place it on the VirusTotal and search it, the community score show it's 0, and we look at the security Windows analysis that all of it tell that the IP address is clean, which is safe from viruses, and we can see the details too in here, where from, US, continent, America, and who is lookup. Okay, just that.
So next, I will continue with true positive. So in this case, our SIEM system successfully identified malicious activity. Specifically, it detected a potential DDoS attack targeting the IP address 138.68.9.83. This alert was later verified using threat intelligence from VirusTotal, which confirmed that the source IP or related IOCs were indeed malicious. This confirmed that the detection was accurate and meaningful, so it is a true positive. So as you can see, the data shows a total of 2,728 records associated with DDoS activities, indicating consistent attack pattern from various source IPs, such as 1.144.155.98 and 1.96.96.41, with the most attacked destination being 138.68.9.83. For true negative, our SIM currently did not trigger any alert for traffic coming from IP address 83.25.22.149, which was expected, irregular, and non-malicious. This indicates that the system is not generating unnecessary alerts or false positive, which is crucial for operational efficiency. This is an example of a true negative, meaning the system accurately identifies normal behavior and ignores it. In this case, 1,475 records were processed without being flagged, which supports the reliability of our threat detection logic. So now we move to false positive. Our SIEM system generated an alert for activity involving the IP address 157.185.179.12, suspecting it to be a potential threat. However, after a detailed investigation, we discovered that the activity was actually legitimate and harmless, likely due to a benign internal process or a routine external scan. This type of detection error is known as the false positive, where the system mistakenly flags normal activity as malicious. Although no actual threat existed, the system still raised an alert, which emphasized the need to fine-tune our detection rules to reduce unnecessary noise. The data shows this false positive case was part of a larger detection group with 2,728 DDoS-related records, suggesting how easily misinterpretation can happen if the rules are not precise. And the last one is false negative. A false negative is the most dangerous scenario. This happens when there is a genuine malicious activity, but the SIM system fails to detect it and no alert is generated. These are often called silent failures because they allow threats to bypass detection, potentially leading to system compromise or data breaches without our awareness. Although no specific IP address is shown in this slide, the key message is that undetected threats are a critical weakness in any security system and require advanced tuning and ongoing threat intelligence to minimize. This is a reminder that relying only on alerts is not enough. We need proactive monitoring, threat hunting, and regular review of SIM performance.